All right, we're gonna work through some notes here. We're going to look at triangles and inequalities involving those triangles based on sides and angles. So with these first two theorems here, we should be able to determine the the smallest and largest angles and the smallest and largest sides of a triangle. So essentially, this triangle longer side theorem tells me that if a side of a triangle is longer than a second side of the triangle, then the angle that's opposite the larger side is the bigger angle. So here would be the larger side out of 8 and 5. So if I go opposite, that means this angle is larger than opposite this angle. So C is bigger than A. Okay, so that's what it's telling you. AB is bigger than BC. So you go to the opposite angles, and measure of angle C is bigger than measure of angle A. Okay. Then you can go the opposite direction. So now we have the triangle larger angle theorem. So the side that is opposite the bigger angle is the bigger side. So since angle A is bigger than angle C, if I go opposite, that means BC is longer than AB, which is what it tells you here. BC is bigger than AB. Okay, so that's what those two tell us. The third theorem here is very simple. It says it's the triangle inequality theorem. It just basically tells me that any two side lengths, or I guess the sum of any two side lengths, has to be bigger than the third side. Because if two side lengths added together is smaller than the third side, then it can't be a triangle, right? Because the two sides couldn't reach the distance of the third side, so it wouldn't even be a triangle at all. Okay, so having that information, go ahead and try 6 through 13 together with your groups, and then you can go ahead and unpause the video when you are ready. Okay, so on 6 through 8, if I am going angles smallest to largest, I'm looking for smallest side, so the angle opposite the smallest side. So the smallest side is 6, so the opposite angle would be C. So I would do angle C. You got to be careful with this. I didn't think about that. You got to be careful with what's an angle marker and what is an inequality sign. So let me try to be a little more clear here. So we'll say measure of angle C is smaller than measure of angle. So the middle one would be the middle side, which is 8. So opposite angle would be angle A is smaller than measure of angle. 10 is the biggest side, so the opposite angle, angle B, would be the largest. Okay. So number 7. Looks like D is the smallest, so measure of angle D is smaller than measure of angle 15 is the second, so that'd be AE is less than measure of angle F would be the biggest. And then lastly on number 8, smallest would be H. So measure of angle H is less than measure of angle J is less than measure of angle G. Okay, so smallest to biggest angles and sides. Okay, the rest of the problems just ask me, is it possible for this to be a triangle? Okay, so I'm looking for the two smallest sides to be added together should be bigger than the third side. So here 3 and 12 is 15. That's not bigger than 17, so this is no. It's not possible. 5 and 16 make 21. Okay, so 21 is not bigger than 21, so again, that would be no. If I look at 11, two smallest, 5 and 7 makes 12, which is bigger than 8, so this is a yes. And then lastly on 12, two smallest, 10 and 3 makes 13, which is bigger than 11, so that is a yes as well. Okay. Then one just written out in words. A triangle has two sides, lengths 5 and 13 inches. Describe the possible lengths of the third side. Okay, so we know that the third side has to be bigger than my first thought was the two sides have to be bigger than 18, right? Because 5 and 13 makes 18. But it is possible that 13 is the longest side. So if 13 was the longest side, 5 plus what would give me 13? So that would be 8, right? So if the values were actually bigger than 8, that would work. All right? So that would have to be third side greater than 8 inches. Okay, because if it's greater than 8 inches, then that means 5 plus whatever that number would be bigger than 13, so we could go that route. Okay? Okay, let's go to the second section of notes. Not any harder here. We're just now looking at inequalities with two different triangles, okay? And we have a couple different theorems that help us out when we're trying to compare two different triangles. So the hinge theorem. The hinge theorem basically tells me that if I have two triangles, okay, that have two sets of congruent sides, then the angle in between them determines which has the bigger third side. So since this triangle right here has the bigger angle in between the two congruent sides, that means this XW or WX has to be bigger than this ST. And that's what it tells you here. WX has to be bigger than ST because that angle is bigger, or the angle between the two congruent sides is bigger. Okay, and then we have the converse as well. So again, if you have two sets of congruent sides on two triangles, then the third side, whichever side is bigger, then the angle opposite that has to be bigger. So C would have to be bigger than F because 12 is bigger than 9. So that's the hinge theorem when you're given the angles, the converse when you're given the sides. Okay, so go ahead and do 1 through 6 together with your groups. So pause the video, do 1 through 6, and then you can go ahead and unpause it when you are ready. Okay, so it looks like 1, 2, and 3 all give me this, the angle. So we're using the hinge theorem here. So I am looking for congruent sides, so I'm good there. So the bigger angle produces the bigger side. So that means EF is going to be the bigger side. So I got to make sure and put my inequality sign where EF is bigger. Okay, so again, make sure congruent sides, bigger angle produces the bigger side, so BC is going to be bigger here. And then on number 3, congruent sides, angles are exactly the same, right? So if the angles are exactly the same, that means the sides have to be exactly the same, so that's going to be equal to, ooh, that's an ugly equal sign. Okay. All right, and then 4, 5, and 6 have us using the converse because they give us the side lengths, okay? So it looks like on 4, it looks like I have 3 sets of congruent sides, which means the angles would have to be exactly the same. So that's where I get that equal sign. Number 5, I have my congruent sides. Bigger side produces the bigger angle, so bigger side of 16 produces that D has to be bigger than A. So D has to be bigger. And last but not least, on number 6, we have congruent sides. Bigger third side produces the bigger angle, so that means A has to be bigger than D. So greater than sign there. So that's the hinge theorem and the converse. You are ready for prep.